During today's experiment, we will be making a total of 8 ionic compounds. For safety purposes, goggles should be worn at all times. Please take caution around the ions being used today. The barium and lead 2 ions are both toxic by ingestion. The hydroxide ion is corrosive and a body tissue irritant. The silver 1 ion is toxic, corrosive, light sensitive, and will stain your skin and clothing. In the event that you spill or touch any of these substances, please wash your hands immediately and notify the instructor. For today's lab, you will need several items. You will need a pipette holder and the corresponding pipettes that are labeled for data table number 1, and another holder and set of pipettes that are labeled for data table number 2. The substances will be available in the fume hood for you to use. Notice that the labeled tape corresponds to the labeled tape on both sets of pipettes and their holders. We will also be using a well plate. A well plate is made out of plastic and it holds several different microscale experiments simultaneously for comparison purposes. The well plate has a letter number system where our first row across is row A, the second row is B, followed by C and D. The columns of our well plate have a number assigned to each, starting with 1 and going through 6. For part 1 of our experiment, we'll be using our pipettes labeled here in yellow. If you notice, the labeled tape tells us what ion this pipette should be used for, so we do not cross-contaminate our substances. To start, we're going to take our lead 2 pipette, acquire some lead 2, and place 4 drops of lead 2 ion into both wells A1, A2, A3, and A4. Next, we're going to find our bromide pipette, fill our pipette with the bromide ion solution, and add 4 drops of the bromide ion to well A1. Next, we're going to take our carbonate pipette, fill our pipette with the appropriate matching solution, and add 4 drops to well A2. Continuing in a similar fashion with the hydroxide pipette, in the hydroxide solution, this time we're going to add to A3. 4 drops. And lastly, sulfate. Four drops into A4. You now should record observations about what we see here. Okay. If you can notice, there is this distinguishable white color coming off of wells A2, A3, and A4. From the top, it looks as though these are liquids. However, if we observe our well plate from below, you may see some solid particles. This may be hard on camera, but I promise you, they're there. Moving on to part 2 with our red labeled pipettes and corresponding containers. This time we're going to take our phosphate ion pipette, fill it up from our beaker, and we're going to put 4 drops in C1 through 4. We're going to start adding to our phosphate ion by making our first ionic compound with barium, which is Ba plus 2. 4 drops into C1. Next will be calcium. Fill up our pipette and add 4 drops to C2. Next is the lead 2 ion. Remember that lead acts as a transition metal and can form multiple charged ions. In this case, we're looking at lead 2, and we'll be adding 4 drops into C3. And for our last ion, silver 1 ion, again a transition metal, this time a transition metal that is actually in that family, will be going into well C4. Again, let's make some observations about these 4 wells. We have formed solids in each of these wells. The coloration of these solids is slightly different than our previous round, where C4, which is where we combine the phosphate and silver 1 ions, have resulted in the formation of a yellow solid. The other solids created in wells C1, 2, and 3 have all resulted in the formation of a white solid, similar to those we saw in part 1 of the procedure. To clean up your well plate, make sure that you adjust your sink to a reasonable pressure. You're going to hold your well plate on an angle as to not splash yourself or a neighbor, and let the water get into the grooves of the well plate to rinse out those chemicals that you have created. You are now to complete your conclusion and discussion questions.